Many people think that mathematics were only made for calculating. Many others think of it as a useless field of science in real life, or a tiring task for the brain. But time has proven them all wrong. Let me give you a glimpse of why.
300 years ago, an Italian mathematician named Leonardo of Pisa invented a sequence of numbers which has fascinated scientists from all over the world. The concept of his sequence is that each of its terms is the sum of the two precedent numbers. So as you can see, O plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 3 plus 2 is 5, and so on to the infinite. And what's more impressive and unique about it is that the ratio of each two numbers of the sequence is approximately 1:6:1834. In fact, the more the numbers of the sequence get bigger, the more this ratio gets closer and in a asymptotic way to the number phi, which is an irrational number just as p or e, and it is commonly called the golden ratio. And thus this sequence can be modeled in the shape of fn equals fn minus 1 plus fn minus 2, and fn over fn minus 1 is approximately the number phi. And I'm going to be trying to draw a representative graph of fn over fn minus 1 for no scale. So 1 over O is impossible, 1 over 1 is 1, 2 over 1 is 2, 3 over 2 is 1.5, and then it just gets closer and closer to the number phi, but literally never reaches it.
This sequence seems to appear in a wide variety in places of nature. For instance, the number of petals in a flower differs from one to another but usually belongs to the Fibonacci series of numbers. Have a look at this one which has 3 petals, and this one has 5, and this one has 8, and these are all exact consecutive numbers of the Fibonacci sequence. But let me get this a step further.
If we gather squares of lengths that are respectively consecutive numbers of the Fibonacci sequence and draw arcs from each square's corner to the other, we'll get a spiral that we found around us surprisingly often. Pine cones, pineapples, the curve of the waves in the sea, starfish, the Nautilus shell. All these compounds of nature have the same exact pattern. And if we run deep in space, we find that even the spiral of the galaxies above us are formed with the same exact design. The Fibonacci sequence appears also in abstract maths, and I think Pascal's sequence would be a great example. I'm going to cross numbers either this way or the opposite way and see what sum of numbers I cross. So first there's no number, and then there's 1, and then there's also 1, and then 2, and then 3, and then 5, and then 8, and if I continue to the infinite, we get exactly the Fibonacci sequence.